it is turning out to be vinyl cyanide. At the same time, nylon is having the two monomers that combine together with the help of condensation polymerization technique to form the nylon 6,6, that is adipic acid and hexamethylene diamine. At the same time, you can see here polystyrene is having the monomer of the styrene. So these all are the things that one has to remember with the names whenever you are learning the polymer section, because the monomer name and the chemical reactions play very important role from this chapter. Let us proceed ahead. Suppose, what is the next question? They are asking us question 4b, draw pH scale for acid, base and neutral solution. So what they are asking, that we have to draw the pH scale, okay, for all the three solution, that is acid, base and neutral solution. Apart from that, they are asking, write the importance of pH in various fields. So what we are going to do is, we are going to draw the pH scale, and also we are going to state what is the importance of the pH in the different fields. You can see in the diagram here, that is, here the pH scale is there from 0 to 7. If you see here very clearly, it is acidic solution, so that is actually going to give the red color, okay, with the litmus. And from it is the pH greater than 7 is actually basic solution, so that is going to give a blue color with the litmus, okay. So it is very clear, your pH scale is from 0 to 14, and pOH scale you can see here from 14 to 0, just the inverse of that. Let us try to understand the importance. What is the importance of the pH in various fields? It is very important in biomedical field to know the urine and blood pH. In chemical laboratory, to know nature of acid, base or neutral solutions. Suppose you are given an unknown solution and asked to find out which one is what, then you can straightway put a litmus. If your litmus gives a red color, it is acidic solution. If it gives a blue color, it is basic solution, and if it gives a no color change, then it is a neutral solution. Another way of measuring the pH is with the help of pH meter also. That can also give the straightway pH value of that particular solution. In paper and textile industries also, the pH plays very major role. In city water supply also, knowing the pH is very important. You often have seen the people coming and asking for the water to taste the samples coming at your home. So there also pH maintenance is very important. In agriculture field, to know the soil nature, pH has its own importance, because you cannot do you can say agricultural activities cannot be done if your soil is having acidic nature. You cannot grow the crops or things on it if you are having the acidic nature of the soil. So in the various fields, pH is having a very great importance, and without pH our life cannot move ahead. Look here. There is one of the most interesting GTU question that is frequently asked in the all examination, that is difference between thermoplastic and thermosetting plastic. This is the most important question that if you will find it in almost all the GTU examination, and a required answer is expected in order to ensure the complete mark from that. Okay, let us try to see what points one has to cover from it. The difference, thermoplastic and thermosetting plastic. It is having the weightage of the 4 marks. Okay, so for that minimum 5 points you are expected to write. Always remember, when you are attempting any difference, the things that you are supposed to do is, you will write down the first point as a definition of that particular thing asked, and the last point of the example. Okay, so the first point, that is thermoplastic. Plastic which softens on heating and hardens on cooling is called thermoplastic, and the thermosetting plastic is plastic which do not soften on heating is called thermosetting plastic. So what happens, thermoplastic is actually getting softened on heating but it hardens on cooling, but thermosetting plastic, it do not soften on heating, and that is why it is called thermosetting plastic. Second difference that is very important, you will cover the technique. Thermoplastic is actually made, or it is formed by addition polymerization, and thermosetting plastic is made by condensation polymerization. Okay, so this is very important. third point, that is it can be remolded, and here it cannot be remolded. Then you can say fourth point is it has low molecular weight and it has high molecular weight. So this is again very important point. You can relate, actually you don't have to mug up all these points, you can just relate the things. The first point that starts with the definition, then you can see that suppose thermoplastic is getting softened on heating and hardens on cooling, that means you can remold it. So automatically your second point turns out to be it can be remolded. Okay, so in the same way on this side, if you can see very clearly that the plastic which do not soften on heating, so if it is not getting softened, it means it cannot be remolded. So this is the actually your second point that automatically gets covered. You can see the third point, that thermoplastics are having the low molecular weight. So if it is having a low molecular weight, it means it is soluble in organic solvent. But at the same time, if you are having that thermosetting plastics are having the high molecular weight, it means it is insoluble in organic solvent. So these 2 points can be automatically related. The remaining point that you can take up, that is formed by addition polymerization, and the example that you can take is polyethylene, and in the thermosetting plastic example is bakelite. So these all are the example and definition and the points, preparation techniques and their nature, their physical property you can cover as a point of difference. After writing all these points, you are ensuring your 4 marks fully. Okay, so this is very important difference that one has to learn how to write down in the paper. Now coming to the numericals, let us try to solve the sums. Okay, so in the numericals you can see here so many things, that there are 3 numericals given in the GTU paper, that is question 4 comprise of the 3 numericals. Question A, that is a numerical of the 5 marks from the water treatment. B, numerical from the ionization chapter, that is chapter 2, and C, the numerical from corrosion chapter, that is chapter 3. So these are having the weightage of 5, 5 and 4. So you can see very clearly 14 marks of the numericals are directly given in the paper. So you are encashing the 14 marks from your side. Let us try to learn the technique. Read the sum. What does it states? A sample of hard water on analysis gave the following result. Okay, there is a one sample of the hard water which on analysis have given the following results, and we have to calculate the total hardness of water in ppm. We are given calcium bicarbonate which is having 81 milligram per liter. Okay, this is the analysis result. Then you have magnesium bicarbonate equal to 29.2 milligram per liter, calcium chloride 11.1 milligram per liter, magnesium sulfate 12 milligram per liter. Okay, so this is one has to remember. Let us proceed ahead to do the next solution to this question. If you see here in the question, what is the formula? Read here the sum. After that, the formula that we are going to use to solve this numerical is W into 100 divided by molecular weight. What is W? W is the data given in the numerical. W value for calcium bicarbonate is 81 milligram per liter. Same way we are having the W value for all the salts. Look here, molecular weight, that is again which one has to learn to calculate, that is given in the table directly that we can use here. See here, for each and every salt we are going to calculate the hardness. Hardness due to salts, that is given by the formula W into 100 divided by molecular weight. For calcium bicarbonate, molecular weight is 162 and W value given from the sum is 81. So what we are doing, 81 into 100 divided by 162, that is 50 ppm. ppm is a parts per million to express the hardness. Then you can see very clearly, that is calcium chloride. Calcium chloride is having W of, look here, 11.1. So you can write here 11.1 into 100 divided by 111, that is 10 ppm. So these two are the hardness for these two salts. Let us proceed ahead with the next salts. hardness due to salts. Magnesium bicarbonate, that is having, you can see in the sum, what is the W value? Magnesium bicarbonate 29.2. 29.2 in 200 divide by 146, that is molecular weight of magnesium bicarbonate, that is equal to 20 ppm. At the same time, you can see here magnesium sulfate, which is equal to 12 into 100 divided by 120, so that is equal to 10 ppm. Okay, so once you are doing all this, hardness is calculated from the formula W into 100 divided by molecular weight. W data is already given in the numerical, and now what we will do is we will calculate out all the things, we will add up all the things. You know, for temporary hardness, calcium bicarbonate and magnesium bicarbonate are the responsible salts. See, look the formula. Total hardness is equal to total temporary hardness plus total permanent hardness, which is equal to 50 plus 20. Whatever you have calculated in the previous data, 50 plus 10 plus 20 plus 10. Okay, so this you can see here, that turns out to be finally 90 ppm. Total hardness calculated for that particular water sample is 90 ppm, that is parts per million. See the next numerical based on chapter number 2, that is pH. What they have asked? Calculate the pH of 4.9 into 10 to the power minus 4 normal HCl solution. It means what? They are straightway giving you concentration of the H3O plus ions. Okay, so what you will write? pH equal to minus log of 4.9 into 10 to the power minus 4. So pH is equal to, what you will do? You know, when you are applying the log separately, it means multiplication becomes the addition. So you are putting the value of H3O plus, that is 4.9 into 10 to the power minus 4. Okay, after that you will separate the log terms, so multiplication becomes addition. At the same time, you can write down here pH is equal to minus log of 4.9 plus log of 10 to the power minus 4. So you can write here pH is equal to minus 0.6902 minus 4. Now there is a negative sign outside the bracket, if you see clearly. Now what we will do? We will simplify the terms. So 4 becomes positive and that becomes negative. So pH value is equal to 4 minus 0.6902. So pH is equal to 3.3098. This is the final answer, that is of the 5 marks. You have to show all the steps. You have to write down the log value, you have to separate the log, where you can say that multiplication becomes addition, then you have to apply the terms separately, and then you will get a final answer after applying the minus sound outside the bracket. Let us see important sum from the chapter corrosion, that you can read here very clearly. Calculate the cell potential and write chemical reaction involved in it. In that you can see very clearly, they are given, actually 2 electrodes are there, magnesium and zinc. Okay, in that electro EMF value, or you can say left hand electrode value, that is given, potential of the magnesium electrode is given as 2.37 volt and potential of the zinc electrode is given as 0.76 volt. So what we are doing, we are applying a very simple formula, that is delta E cell is equal to E of left hand electrode minus E of right hand electrode. So delta E cell is equal to 2.37 minus 0.76, which is equal to 1.607 volt. Okay, so this is very important. So what we are doing, left hand electrode is our magnesium, right? So we are having the value of 2.37 given in the sum, and right hand electrode is our zinc, which is actually seen in the numerical. So that is having the potential value of 0.76 volt. Here you can minus the things and you can get 1.607 volt, that is the final delta E cell EMF calculated. Okay, so this numerical carries 4 mark, and for that you are supposed to show the simple steps involved. Let us try to understand very important questions. That is, question 5 consists of 3 parts. Part A of 5 marks, Part B of 5 marks and Part C of the 4 marks. In that you can read out the question. The first question that is seen here is, write the main functions of the lubricant, explain boundary lubrication with diagram. Okay, so the first question, what to write, how to write and how much to write. The main function of the lubricant you have to first emphasize. So that is our first duty that is asked in the question. The lubricant actually reduces wear and tear between rubbing surface. It reduces wastage of energy, reduces metal expansion, maintenance cost, corrosion of machine part, reduces impact, reduces power loss. Okay, so this one has to remember, right? So this is very clear. This is actually question of the 5 marks. Let us proceed ahead to explain boundary lubrication. You can see the diagram given in the boundary lubrication. That is, there is a lubricant film, okay, and like high speed load is there going on above the surface, and how it is actually going to act in the diagram. Let us try to describe. Boundary lubrication is done when direct metal to metal contact is possible due to certain reasons. So this one has to remember. This happens when shaft starts moving from rest, speed is very low and load is very high. Viscosity of oil is too low. At that time boundary lubrication is used. These conditions are very important to mention. When is the boundary lubrication used? These are the conditions. Let us move ahead. Space between moving part is lubricated with oil layer. This oil layer cannot be removed easily and direct metal contact is avoided. In the diagram you can see here, see, the space between moving parts is actually lubricated. You can see the lubricant film that is actually applied between the two moving parts as shown in the diagram. So what is this? These oil layers cannot be removed easily and direct metal contact is avoided. Graphite and molybdenum disulfide is used for boundary lubrication. Okay, so this one has to remember. MOS and graphite, these two are the examples